just on like the blank, the first side that you have here, T-chart. This is going to be, X is going to be the first column, and then the probability of X is going to be the second column. This is called a probability distribution. And then the variable, when we talk about a probability distribution, it's called a random variable. Okay? Thanks. Right over there, grab one of these right here. So, what a random variable is it's going to be a value that randomly, let me restate that here. That occurs based on a probability experiment. You don't need to write that down if you don't want to. I just want to say it just so we can refer back to it. So I'm trying to give you an overview of everything, then we'll come back and look through little things here in a second. So here's my experiment. My experiment is rolling a 6-sided die. And X, the random variable X, is going to be the roll of the die. So what are the values that X could have? So then that's what you put in the columns. And then you, through whatever methods we can figure out, in this case it's pretty easy, figure out the probability of each of those rolls. So the probability of a 1, 1/6. So X is 1, then the probability of that occurring is 1/6. Okay? So we're just built a probability distribution. Okay? But that's what this chapter is about, is probability distributions. Okay? So let's look at how each of these variables are defined, and then let's think about what are some of the values that the variable could be. Okay? So like if we say that X is the number of sales calls a person can make in one day, then X could be 0, 12. Could it be 1/2? No, 24, 1, 2, lots of different values, right? How about hours spent on sales calls? How long do you think that somebody? No more than 12 hours? What if they were working overseas? They were working time zones. They were like working 3 time zones. They worked like 18 hours a day. Yeah, but could they go?
Well, they could.
3/4 of an hour?
Yeah.
3 hours?
Yeah.
1 1/4 hours? Okay. How about the value on the right on the die on a roll? Well, we've already done that, 1 through 6, right? How about the sum of the roll of 2 dice? We could have 12. We could have 2. So a lot of different sums, right? How about the value of a 1-digit random number generated by a calculator? 0 through 9. How about the difference of 2 random numbers? 0 minus 9?
Yeah.
9 minus 0? I'm kind of saying that maybe you could go all the way from maybe if I let negatives occur, maybe -9 to 9. Yeah, so like if you had like one digit number was 0, and then the other digit number, or the one digit is a 9. Yeah, right. So depending on how you define that, right. Um, hours worked by teachers, 0, summer. 40, 40 and a half, 37.75, right? So now my point of putting some of these in here is because we can really classify two things, random variables, as either discrete or continuous. Okay, so let me talk about discrete and continuous, and we'll maybe look at a couple of those examples. Now, in this chapter, we're only going to be working with discrete random variables. Discrete random variables would be ones where you could actually list, there's a countable number, or there's a finite number of values that your variable could be. Whereas on a continuous one, if we look at like this one, hours, you could have a fraction of an hour. You don't have to have just a single 1 hour sales call or whatever. You could have any fraction. So that's a continuous type of variable. Okay? So I think we probably understand that. Again, we're only going to be working with a discrete situation where you can actually list the values of the variables here and then find the appropriate probabilities. Okay. So next page. What would you say? You write them down. Write down what you think each of those are. Number 1? Number 2? The continuous or discrete, do you think? Yeah, you could have a fraction of a gallon. So the volume of the gasoline in the 21-gallon tank, it could be 20.56 gallons, depending on how you measure it. Okay, now we're getting into the real stuff. Let's take a look at the distributions. Let's all do all kinds of stuff with them, okay? So write this down, the distribution that we've been working with. And answer me this question. What does that mean? Right, so what's the sum of the probabilities? 1. And that would have to be true in any probability distribution. Okay, because if you've listed all the values that are possible and you write down the probabilities of every possible one, then the probabilities have to add up to 1. Okay, so let's do this now. Let's make a visual display of this guy. Let's go ahead and make a histogram. So on your horizontal axis, put X. On your vertical axis, put the probability of X. And then let's list, for this problem, the number or the values of each of the values of the random variable. And then here, let's go ahead and put the probabilities, which there's only one, so this is kind of a boring probability distribution, but let's just put a scale of 1/6 on our vertical axis. Okay, so I'm going to move a half a unit to the right of 1 and a half a unit to the left of 1, and I'm going to make a bar around that 1 to represent the probability of 1 and 2. Now, here's kind of a weird question. It might seem weird to you. What's the area of this bar?
7.
The area of this bar here is 7 units. So,
so 1 bar.
so this area is 1? It's 1/6 because what's the length? 1 unit there. So it's a 1 by 1/6. So it's kind of weird that this segment, the way we've scaled it, looks longer than this. But this is 1/6 and this is 1, and 1 times 1/6 is 1/6. So the area of this bar is 1/6, 1/6. And so just like the sums of the probabilities have to add up to 1, the sums of the areas of your histogram are going to be 1. Okay? Now that's not such a weird thing here, but the thing that is weird is that that works for any distribution. Okay? So like if I work with a continuous distribution, and this has a function, I don't know what the function name is of right now, but the area under this curve is 1. So when we start talking about probabilities, we're going to talk about, like on a continuous distribution, people might ask, hey, what's the probability that your IQ is between 100 and 150? Well, what they're saying is, what's the probability that if you had to find a point, that it's between this value of 100 and this value of 150? So then we start looking at the areas of that as probability, because the area of this whole thing underneath it is 1, and then there's going to be some formulas and some stuff that we're going to use to calculate continuous distribution probabilities. Okay? But it's important you know that the area of the distribution is 1. Okay? All right, let's make a probability distribution down here from that information. Okay, so we've got a psychologist has administered a personality inventory test for passive-aggressive traits to 150 employees. Individuals were given a score from 1 to 5, 1 extremely passive, 5 extremely aggressive. The score of 3 indicated neither trait. Construct a probability distribution for the random variable x. So x is going to be the score of the test. So what's my chances of randomly picking somebody and that they get a score of a 1? Right, so you took 24 divided by 150, right? So I'll tell you all the percentages. That would be 16, 22, 28, 20, and 14. And we could make a distribution. We could make the histogram for that if we wanted to, which we don't need to right now. So my only point is make sure these are probabilities, otherwise I'm counting it wrong. So if you just put these guys right here, that's not a probability distribution. Okay, you got to have probabilities in that column.
So if you add like the decimals, those will come out to equal 1 if you add.
Yep, and an error in rounding a little bit is okay, but yep. Yeah, if they don't, then something's screwed up. Okay, so we're gonna do this now. We're gonna calculate the mean of the distribution, and we're gonna calculate the standard deviation of the distribution. We're only gonna do the 1 die distribution. We're not gonna do the 2 dice distribution. So you can kind of ignore this. You might have to write over the top of it a little bit. Okay, so let's just review here a little bit. The mean is equal to the sum of x times p of x. So what should I do first here with my x's and my p of x's? Let's write 1/6 here first, I guess. What do you think I should do? Say again? So you think I should do addition first, or do you think I should do multiplication first? So like, let me do this. Is this different than this? Yeah. So here it would be saying find the sum of the x times the sum of the p of x. Here this is saying find the sum of the product. So I want you to find the product first of each x and its probability. Okay. So I want you to go and do this. Okay. Now, if these were decimals, work with them in decimals. That actually the math works pretty good if you leave them as fractions. 1 times the sixth. 2 times the sixth. 2 sixths. I'm going to leave it as 6 because I'm going to end up adding them up here. So guess what I got to do with these? Here I got to add up those products. These are all products here. Add all those up. So it would be 3, 6, 10, 15, 21 over 6. What's that equal? 3.5, 3.5. Now that in itself is actually something important to know. Is that if I roll a die, what's the average of all the rolls that I could roll all day long? What's the average going to be? 3.5. Are you ever going to roll a die that is a 3.5? No. So the average doesn't have to be one of the values of the random variable. Okay, that's important. Now let's go back to the graph of our distribution here. And let's talk about where 3.5 is at. Look at that guy. 3.5 right there. I want you to write this on your graph. The mean is right there. That's the center of balance. Your mean is, we talked about this before, it's like your center of balance of the distribution. So if I had something like this, is the center of balance going to be right here? No. So this would have like 3/10 to the right and 3/10 to the left. Your center of balance is probably going to be about right here somewhere. Okay, so you can kind of use that as an estimate for where your mean is at by trying to find that spot if you just do it visually. Okay. So we've got the mean. So now let's look at the standard deviation formula. So your formula is the sum of x minus mu squared times p of x. Notice that there's no dividing by n in here. Well, that's really because like your probability you've already divided by n. It's like your relative frequency kind of here, f over n. Okay, so what happens first? Your deviation is going to be done first. Then your squaring is going to be done second. Then your multiplication, and then the sum, and then the square root. That's going to be the order that they're telling us to follow here. So let's add to our table here a little bit. What do I put right here, do you think? What am I going to do next? X minus mu. So 1 minus 3.5, negative 2.5. 2 minus 3.5, 3 minus 3.5, 4 minus 3.5, 5 minus 3.5, and 6 minus 3.5. And what do those values represent? It represents how far that value is from the middle of the distribution. And then we square them. So your next column should be squared. And are you going to have to do this all the time? No, I'm going to show you how to do this in a calculator too. And then the last step is to take this squared difference times your probability. And so if I took this times a 6, that would be like dividing by 6. So that's 1.04. 0.375, 0.04. And then add that up. If you add that all up, you get about 2.91. So that's this guy right here. So then just take the square root of that and you have your standard deviation. Which again is a measure of the spread, that typical distance that the values are from the middle. Okay? Yes, sir.
Do we have to have a separate column for the x minus the mean, or can we just have the x minus the mean squared if we're able to like?
It's up to you. Okay, so let's try our calculator. Let's try to do this on our calculator. So try to remember, how did we enter the data in? If I remember, like, take a guess what button I should hit. If you guess wrong, I don't care. Stat? So like some people guessed last couple periods, they said guess math because we've been working on math. Well, we can't really edit any data. We could do a bunch of probability stuff there. So math is a big button for us, and stat is a big button for the statistics class. So we want to edit our data, so that's where we're at. Okay. Now, I have mine entered in, but I'm going to pretend like that's a bunch of other stuff. So I'm going to go all the way to the top and clear out my lists. So go to that, hit clear, and then enter. Now, again, remember, if you lose a list, go to Setup Editor if you don't have that in your options. Okay. So now go ahead and put in your random variable into list 1 and put in the probabilities in list 2. How do you get 1 over 6 in your calculator? Just like that. Divide, right? 1/6. Probably other ways, but this is a lot quicker. How do you get? So what are you telling her to do? Alpha what?
You can get like fractions of doing alpha and then y equals,
And then you
and
can
then you can just make a fraction.
if you-
Oh, okay, I got it. Okay. So she's saying this. She's saying
up here.
if you go alpha y equals, there's your fractions. Okay. So my data's all entered in, right? Go back to the stat menu. Go over to calculate. And how many variables do we have here? We have one random variable, right? So we're doing one variable statistic. So go to one variable statistics. Anybody have an 83 calculator? Okay, so then we're all good. Make sure that your list is in your L1 and L2. Make sure that that's right and calculate it, and you're good. So they have this labeled as X bar, but this is not a sample. This is our whole probability distribution population. So really this is 3.5 is our mu, and then 1.7 is our standard deviation. Okay. Okay, let's try one more thing. We'll call it a day. So if they ever tell you to find the expected value of a distribution, it's the mean. Okay, and I'll try to talk you through why would they use the word expected value. We'll talk about that here in a second. But the expected value is the mean. So let's calculate the mean of the distribution. Well, first we got to make the distribution. Okay. So in this situation, you can make a table here, and we'll fill it out in a second. Okay, so the problem says we have a raffle where there's 1,500 tickets sold at $2 each, and there's 4 prizes, 500, 250, 150, and 75. Okay, you buy one ticket. What is the expected value? What is the average of the gain? So when they say they're trying to find the expected value of the gain, then that's really defining for you that you need the random variable to be the potential gain that you could have on one ticket. So we got to think of X as the amount that we could gain on one potential ticket. Now, 500 is not how much money you would gain in your pocket if you purchased one ticket. 498 would be the amount that you would gain if you won that prize. Now, what's the probability of winning 400 or of gaining $498? 1 over 1,500, because there's 1,500 tickets. So do that same thing for the other winning tickets, which would give you $2 less than what you actually win as a gain. Right. Okay, there's a huge issue with our probability distribution right now.
Doesn't add up to 1.
Right. So don't ever calculate an expected value on something that's not even a probability distribution. We got to figure out something else here. What's your other potential gain?
-2.
Very good. The most common thing that could happen, right? What's your chances of losing?
14.
Very good. So again, we could put that all into our calculator and list 1 and list 2 and do it out. I'm just going to do it manually, okay, when they're fractions and it doesn't work out too bad. I'll do the math for you. So this times this, right? Remember that mean is the sum of x times p of x. So x times p of x would be 498 over 1500, 248. 73 over 1500. And then 1496 times 2, 2992. So negative 2992 over 1500. So if you add these all up, I didn't write it down. If I add up all the positive numerators and subtract and then subtract it from the negative 2000, I'm going to calculate that real quick. I think you get negative 2025 over 1500. So if you divide that out, you get negative 135. So we'll talk about that. What would the histogram look like? Negative 2, way up, and then you have a little bar at 73. You'd have a little bar at 148. You'd have a little bar here. Where's the middle of the distribution? Way over here, right? So at negative 135. So are you ever going to lose 135? No, that's the average loss on a play. So if you took 135, the average loss per play, times 1500, what do you get? What do the people lose on average to the people running the thing? What is it? You know what it is? Negative 2025. Okay. Now think about this. How much is the company bringing in altogether? 3,000. How much are they spending on tickets? They're spending, or prizes? 750, 900, 975. So if you subtract 975 from that, that's what the runner of the game is making, right? And so if you average that out, isn't that average out to $1.35 a loss per ticket? That's how it all works together. Okay. But in terms of strictly the distribution, the expected gain is a loss of $1.35 per play. Okay. Now, I'm going to do the same thing. I'm not going to do it today, but I'm going to put that into the calculator for the North Dakota Lottery. And I'm going to show you what the expected loss is on each play of the cards, lottery, okay? So you can see that. Okay, so the assignment over there is not due until next week. So you'll have a little time to work tomorrow. I'm going to do an ACT review. We're going to do that Friday and Monday. Even if you're not taking the ACT, you're going to do the review for me. And then we'll do that test. So maybe I'll be having like that post-traumatic.
Yeah. Yeah, we're all having flashbacks.
So this you don't need to do. This would just be maybe an example that I'll do to kind of talk about some things tomorrow. So just hold on to that. Sure can.